Here in this example, we are doing the same thing, except we have a polyatomic ion instead of a neutral molecule, but that's okay. So we have the nitronium ion, okay? The procedure is going to be the same as the first example. Let's identify the elements present. So what kind of atoms do I have in this polyatomic ion? Well, I have a nitrogen atom, and I have two oxygen atoms. So I have two of those and one nitrogen atom. Okay? Well, how many valence electrons does each nitrogen atom bring to the table? Here. Group 1A, 2A, 3A, 4A, 5A. So 5 valence electrons for that one nitrogen atom. Oxygen is in group 6A. So every atom of oxygen here, excuse me, has 6 valence electrons, but how many oxygen atoms do I have? 2. So 6 times 2 would be 12. 12 valence electrons, so for a total of 17 valence electrons. But we're not done, because this is a polyatomic ion. Now, the reason molecules are neutral is because the number of protons equals the number of electrons. You have to remember the charge on a proton is positive and the charge of an electron is negative. So if I have 17 protons and 17 electrons, those charges cancel each other out. Okay? But here we have a polyatomic ion with a net charge of +1. So what does that mean? Well, what that means is what I'm going to have here for a polyatomic ion with a positive charge is a reduced number of valence electrons. So for every +1 charge on the polyatomic ion, I have one less valence electron than I should have. So because the charge here is +1, that means we've lost 1 electron. And so we really only have 16 valence electrons to work with here. So for some reason, in some chemical process, 1 electron was lost, ionized, and so this would be our answer, 16 valence electrons.